In this video, we're going to be talking about resistance against conductance. Okay, so on the board we have resistance and conductance. What are the difference between, or rather, what is the difference between resistance and conductance, as well as resistivity and conductivity? Now, in our other video on Ohm's law, we talked about the following proof. I'm going to go straight and write on the board. Okay, we say that the current density is directly proportional to the electric field density, of which then gives us conductivity times E, of which G is I over A, and this is equal to sigma times E, which is V over L, making V subject. So we're going to get V is equal to L times I over A times sigma. Okay, now all these proofs are in our other video on Ohm's law. So if you want this proof and understanding on this, you might as well want to watch them still on our playlist. Okay, so from here, V is then equal to I times rho, okay, times L divided by A, of which we then finally said V equals I R. Okay, now this was the formula we proved on Ohm's law. Okay, now where does resistance come in? It comes in by the fact that we've replaced rho times L over A by what now? R. So I cannot come here and then I will say resistance is equal to rho times L divided by A, of which area is the area of the conductor, L is the length of the conductor. So we can see that R depends on the various what now quantities. R depends on length. So see that resistance depends on length of a conductor. Okay, that's one thing we should take note of. Length of the conductor, okay, as well as the area. Okay, it will also depend on the area of the conductor. And you can see from the formula that it's inversely proportional to the area. So the more the area, the less the resistance that is being expected, and then the more the length, the more resistance that is being expected. Now also resistance will depend on temperature. Okay, resistance depends on temperature. Resistance depends on temperature, but the temperature is not according to this formula that it depends on. It depends on what we call a temperature that is similar to that of linear expansivity, which is also something we're going to talk about. Okay, we're going to talk about as it will be a video on our playlist. Now, the first thing it depends on is the nature of the material. Okay, the nature of material. That is why you notice that silver is a better conductor than copper. Not that copper does not do well in terms of conducting electricity, but silver is a better conductor. This is because of the nature of what now? Silver. Okay, and then copper is also a good conductor because of its nature as well. But then there are rankings to all of this. Silver is generally the best conductors you find. Okay, but it's too expensive, so most times we don't make use of it in building. Imagine staying in a house that is being built by silver. What do you think will happen in the next 2 to 3 weeks? These things will get stolen. Okay, now here are the properties or values that resistance depends on. Now it's also important to take note that resistance is being measured in ohms. Okay, here is the symbol for ohm. Resistance is being measured in ohms. And then resistivity, this guy here, which is resistivity, this row, resistivity, okay, I'm going to write it, resistivity, okay, is measured in ohms meter. Because you notice that 1 meter cancels 1 meter, you will be having m times what now? Ohm. So it's measured in what now? Ohm meter. Okay, so resistivity is measured in what now? Ohm meter. Now that is that for resistance. When you now come to conductance, you will not be having the slight opposite of everything we are having here. So for conductance, we have resistance. For resistivity, we are going to have what now? Conductivity. Okay, now for conductance, conductance is represented as G. Okay, conductance is the reciprocal of what now? Resistance. Conductance is 1 over R. So where resistance is the what now? Opposition to flow of current that is traveling through a conductor, conductance is now the inducement of that current. Okay, resistance is trying to what now? Oppose the current, and conductance is not trying to what now? Induce, that is help the current to what now? Flow through the wire, and it is the reciprocal of what now? Resistance. Now what about the unit for conductance? Since you said the unit of resistance is ohm, the unit of conductance is now the reverse. So now it is from the end to the front. So instead of OHM, that becomes MHO, that becomes what now? Mho. So conductance is measured in what we call mho. Okay, another unit for measuring conductance is Siemens. Okay, Siemens is also another unit for measuring what now? Conductance. So if we want to get the formula for conductance, we can choose to substitute that of what now? R into this formula. Now we'll substitute R, which is, okay, but we are going to take note that R is equal to rho times L divided by A. Substituting into this equation, we're going to get G is equal to, putting this here, we get L, we get A divided by rho L. We don't stop there. Now 1 over rho is also a constant, okay? 1 over rho, okay, is also a constant. Conductivity, which was something we replaced with here. 1 over rho, we replace it as what now? 1 over sigma, rather, we represented it as what now? Rho. So 1 over rho is also what now? Sigma. If I choose to substitute, we're going to get G is equal to rho A divided by what now? L, okay? So you can now see that G is the formula for calculating what now? Conductance. R is the formula for calculating what now? Resistance. They are similar, but what now? Different. Exactly opposites of each other. So where resistance increases with what with length and decreases with area, conductance increases with what? Area, and decreases with what now? Length. Of course, an increase in length. So you cannot say that the conductance depends on what now? Area and as well the length, just like the what now? The resistance. But in the reverse direction, that is, they are now what now? Reciprocal of each other. Okay, so you notice that the relationship between conductivity and resistivity, they are quite easy to remember. Resistance is 1 over conductance, or conductance is 1 over resistance, as well as resistivity is 1 over conductivity, or conductivity is 1 over resistivity. Okay, now how about conductivity? What is the unit for measuring conductivity? We did say that the unit for measuring resistivity is ohm meter. What about conductivity? It becomes 1 over ohm meter, right? So the unit for measuring conductivity is measured in per ohms per meter, right? So we can now say per ohms, okay? Per meter is the unit. Or we can simply say Siemens per meter, of which what now? This one is per ohms is what now? Siemens, okay? So we can simply say or Siemens per meter, okay? That is also another way of what now? Measuring it, okay? The main aim is just to take note that conductance is what now? The Siemens. When you put it in the formula, what you get is as easy as that, okay? That would be Siemens divided by meter, okay? So it's that easy. Here is the relationship between resistivity and conductivity, okay? So if you're having some confusion about these guys, it's all on the board. You might want to watch the video 1 or 2 times to get more understanding, and take notes on your record books, okay? It is that easy, okay? So problems on this will be tackled in our future videos, still on the playlist. Do well to leave a question in the comments if you have one, and then like the video if you did learn something from it, okay? Don't forget to show your friends, and as well hit the subscribe button so that it will help us to produce more videos, and then we'll get encouraged to produce more videos for you guys, okay? That is how it is being done. See you in our next video. Bye.